Hello everyone. I hope you have enjoyed the last two lectures of the linked list where we have discussed the brief definition of the linked list properties, different type of linked list. In the last lecture specifically, we have discussed the advantage of the array and the disadvantage of the array, the advantage of the linked list and disadvantage of the linked list. We have also seen how to define a node using the structure code. So node have the two part, the data part and the next part. Next contains the address of the next node. So data type is the list node star, where is the data type of the data element is the integers. We have seen what kind of the operations we can perform on the linked list ADT, like the traversing a linked list, inserting an element, deleting an element, searching an element, etc. So in today's lecture, we will deep dive in the insertion code. Specifically, we'll cover only insertion at beginning, but we will cover each line with the great clarity. Okay, so we'll first pictorially see how to insert a new element at the beginning of the linked list. Then we'll see the pseudocode followed by the exact code, and we will understand each line, what it does and what is its meaning. So if you understand this each line by line, you can think yourself the other code, like the insertion at the last, insertion at the intermediate position. So you will be, my aim is not to just give you the solution or the correct code or the correct pseudo code. My aim is to make you think, and so that you are capable to think on your own the different logic to perform on the linked list. Okay, so we will proceed to the today's content. So today's we'll discuss insertion at the beg. So it takes the two things. First thing is that list node double pointer head. So we'll discuss in a while why we are taking a double pointer here, and then it takes a new element that to be inserted. So we'll go through the pictorial explanation. So this is the initial content of the linked list. So we have three nodes in the linked list. So first node, the data is 15, second node data is 7 and the address is the 600, third node the data is 40 and the address is 700. So you can see the data part in the first node is 15, next part is 600, in the second part of the node, second node, the data part is 7 and next part is 700, in third node data is 40 and next part is null, and the head contains the address of the first element, that is 500. Now we have to insert a new element 50 at the beginning. So we have created, so this is the thing, so we have created a new node. So that is the first operation that we are going to do, that we are creating a new node. And suppose that node is being created as 400, node is being created as 400. So now the next part we will do, that we will fill up the content, because there is no restriction on the linked list that overflow. So there will not be any condition like the stack or the queue that no new element can be inserted. So we are sure that in the linked list we can insert a new element. So we'll create a new node that suppose that address is 400. We'll put the data into the data part. So we'll put the 50, and then we will put in the next part we will put the value of head. So we will put 500 here. So this becomes the third part. So first part we have created, in the first part we have created a linked list. In the first part we have created a node and the address of the node is 400. In the second part we have put the data into the new node data part. In the third part we have put the new node next equal to head. Okay, so now pictorially it means that both head and the new node is pointing to this second, the previous first element. So still the first element is 500. Now we have to update the head. So we need to cut this connection and we need to update the head. So we are going to update the head. So the new head should be what? So can you tell what should be the new head, the value? So what is the first element now? First element now is 400. So head should be updated as 400 instead of 500. So it will contain the 400. So the new connection will be established. So new connection, so the first node becomes this. So this is the fourth operations, updating the head. So this is the pseudocode. I have not written very formally, but given the main point, like we have created a new node, we have put the x into the data part of the new node arrow data equal to x. This is the second part. In the third operations, we have put new node arrow next equal to head. So we have updated the new node next to the equal to the head value. So in the final part, we are updating the head. So previous head was 500. So we have cut the 500. We have modified the value of head. Instead of 500, we have put to 400. So we have established the connections from head to the first node. So now the first node become 400. I hope this pictorial explanations to add a new node at the beginning and the pseudo code is clear. So if you have any doubt, please comment your doubts in the query section. I will be very happy to answer all your doubts. So we'll now proceed to see the codes part. So this is the code part. So it is hardly 8 lines. So we have a struct list node, double pointer head and integer x. So we have taken a new node, a temporary node that to be inserted. So actually what new node variable will be like this. So new node variable will be like this. So new node is a variable like a head. So it contains some address of a node type. So by this line, by line number 2, you are just defining a new node variable and there is no value here. So so now we are going to create a new node. So in the new node equal to malloc in the line number 4, malloc struct list node. So by line number 4 will actually create this node. So this is very important. Line number 4 is going to do the major task. It is going to create this node and return the void pointer. Malloc returns the void pointer. Then while we are assigning to the new node, it will be automatically typecasted to the struct list node star pointer. So the mistakes here. So what the malloc does, malloc allocate the memory. It takes the how many number of bytes you need and it allocates the memory. So I often tell student, consider malloc as a bulldozer. So if you need a space for a college, give that amount, that 1000 square meter or 1000 square foot, it will create a empty space so that you can construct a college. Or if you want to construct a hospital and you need 500 square feet, so give the malloc that you need 500 square feet, it will create an empty space for you and it will return the address. So you can imagine malloc as a bulldozer that clears the space and that allocate the space. So it returns a void pointer and that void pointer will be automatically typecasted to the new node. So here, to know how much size is required to store a node, we need to know the size. So size of is the inbuilt function. So we use the size of, then struct list node. So here we don't need the size of the list node pointer. We need the size of list node. That's why we have written struct list node. We are allocating a node, not we are allocating a node pointer. So this is very crucial. By this line, malloc size of struct list node, you are creating this node and after this it will return 400. That 400 will be assigned here and you in the new node value, that is a pointer, you will put 400 into new node. So that is the explanation of line number 4. That is very crucial. So you can pause and re-see the video, last few second video if you don't understand. So I will repeat. Line number 4 creates a new node. It returns the address of the new node and new node is a variable that contains the address of any node type. So this 400 will be assigned here. Now the next part is simple. New node data will put the 50, that is x is 50 here. So in the data part of the new node we'll put 50. In the next part we are going to put the 500, the previous content of head. Why? Because the 500, this node is going to be the second node in the linked list now. So this is going to be the first node. So first node next should contain the address of the second node. So the first node next will contain the 500. So here new node next will be star head. So head is a double pointer, that's why we are taking the star head. Then we are updating the star head equal to new node. So we are updating, instead of 500 we are updating it to the 400. So now you might be asking why we are using the double pointer instead of a single pointer. So I will explain that here. So this is a head. Head is what? Name of the variable. Head is the name of the variable, and it now contains the 400. Suppose previously it contains what? Head contains 500. So 500 is what? 500 is the value. So 500 is the value, head is the name, and what is the data type of the head? So it is the struct list node star. The data type of this is struct list node star. Okay, then there might be an address of the head. Suppose the address of head is 7839. So if you want to modify the head to the 400, and if you want to just pass the value 500 inside a InsertAtBeg function, when you return back to the main function, so from the main function you are calling the InsertAtBeg function, right? From the main function you are calling the InsertAtBeg function, and you are passing the value of head. So when you pass by value, it makes another copy. So the actual variable is not passed, there is a separate container. So from here 500 is passed to the another container, though name may be same, but it is a different. So for your reference, just revise call by value and call by address. In the C programming, you can use any book or any reference to revise call by value and call by address or call by reference. So if you pass 500, InsertAtBeg, inside InsertAtBeg you modify this 500 to 400, but this 400 will not be reflected when you go back to the main function. If you want to get it to be reflected in the main function, changed value of head, so when you are cutting the value, when you are updating the value from 500 to 400, and you want this 400 to be reflected inside the main function, so what you need to pass? So you need to pass the address of the head 7839. Then only it will be reflected in the main function. So what is this? So what is this data type? This is the list node double star, because this is a pointer to a pointer. So this 7839 becomes the list node. So 7839 become pointer to a pointer. So it become list node star star. That's why here we are sending list node star star head. That we are not sending 500, we are sending 7839, because we want the head to be updated, and that updation should be reflected in the main function and everywhere. That's why we are sending a double pointer. I hope this is clear. So to you, if you have any further doubt, please pin down your comments or write your doubts in the comments. I will be very happy to answer you. And so we'll proceed the insert at the last and insert at intermediate position in the next video. So you have to be very clear with the pictorial descriptions of InsertAtBeg and pseudocode and the code, and specifically what the line 4 is doing, why we are passing the double pointer of the list node, not the single pointer, how does it affect. So that's all for this video. I hope you enjoyed the content, and this pictorial diagram for each line of code is clear to you. Thank you very much for listening this video. I will wait for your feedback, comments and the suggestions in the comment section. Thank you everyone.